I want you to open your packet to this particular page. We can stop the chatter. You can work with the person next to you. If there's not somebody there, you're just kind of stuck working there by yourself today. It's all right. It's not going to take you any longer. Do you want to sit next to Grant? Grant, do you want her sitting next to you? That would be no. I said no. That's right.
Do it like that.
So, there we go. That's where we're at. Listen, on this first thing, we're going to be talking about probability today. What is the probability that something would happen? Is it 100% chance? Is it 50-50? Is it more likely, less likely? That's what we're going to be talking about. If you take a look at this page, they said work with a partner to decide how many of the 6 possible results of rolling a number cube match the described event. So, what's the possibility? How many numbers on a number cube are less than 7? 6 of them. So, on that line, let's just go ahead and put a 6. How many numbers on a number cube would be an 8? 0. Go down that list and figure out how many times that event could occur. And then you're going to organize these. Which one is the least likely, being a 1, to the most likely of happening to being a 9. And we're going to organize that over here on the side. Everybody understand what we're doing? I'm going to give you a few minutes to kind of put some numbers in here. Rolling a number greater than 4. How many times could we do that? 2. Rolling a 5. 1. Rolling a number other than 6.
5.
Rolling an even number. 3. Rolling a number less than 5.
4.
Rolling an odd number. 3. And rolling a number divisible by 3. 2. 3 is divisible by 3, and 6 is divisible by 3. None of the others are. Now, the first thing we're going to do is we're going to identify the least likely one to happen. Rolling an 8. Not going to happen, is it? There isn't any 8s. Okay? We're going to put also then the most likely one to happen. Okay? Rolling a number less than 7. So I've identified my outside ends of this. I knew which one's least likely and which one's most likely. What's next after 0 possibilities? Rolling a 5. We're going to make that a 2. What's next after that? There's 2 of them. It really doesn't then matter which one we label as 3 and which one we label as 4, because these 2 are the same. They're exactly the same. What's next? Rolling an even and rolling an odd. We're going to label that with a 5 and a 6. Those 2 are also the same. Oops, I'm on the wrong one.
Yeah. What? Oh, no. Whiteboard, why?
Right, that was 2. What was it? There. I put it back.
Oh, smart bird words.
Now I erase it. Now I'll put it where it belongs. Better?
No, I'm sorry, Charlie. You have a flash full of perfection.
What's next? The one with 4? This would be 7, and then this one would be 8.
I know that.
Okay? Now, we're going to come back to this page in a minute, but I want to talk about terminology when you're dealing with probability. So if you flip to that next page, just going to talk about the words that we're going to deal with. We're going to be dealing with, in this module, experimental probability. And an experiment is an activity involving chance in which results are observed. So you could be talking about flipping a coin. What's the chances of flipping a head? 50, 50. 1 out of 2, right? Each observation of the experiment is a trial, and each result is an outcome. If I had a deck of cards, and I was picking a single card, that would be the trial, or that particular event taking place. The outcome would be whatever the results was. How many numbers are in a, how many cards are in a deck? Standard deck. 52. How many suits are in a standard deck? How many cards are in each suit? 13. Those are things that most people know, honestly. There's 13 clubs, 13 diamonds, 13 hearts, 13 spades. Okay? There's 13 of them. Because 13 plus 13 plus 13 plus 13 is 52. Okay? A standard deck, it didn't say with jokers. There's 54 if you got the jokers included. Okay?
Why so serious?
Okay.
Why so serious?
When you're figuring the probability of an event taking place, it's written this way. And whatever that event might be, maybe you're talking about a standard deck of cards and you're talking about the probability of drawing a queen. Well, how many queens are in a deck of cards? 4. That would be the number of times that the event occurs. And what are the total number of equally likely possibilities in a deck of cards? 52. So the probability of getting a queen would be 4 out of 52. And we always should simplify our fractions, and this is going to be 1 out of 13. Okay? So, when you're figuring the probability of an event, you take the number of times the event occurs versus the number of total possible outcomes that there would be for that event. Okay? Now we're going to go back to this chart. And we're going to decide from this chart if an event is impossible. In other words, the probability of it happening is 0. If it's unlikely, in other words, it's close to 0. If it's as likely or not, that would be a half. If it's more likely, that means that it's getting close to 1. Or if it's certain, that means it really would have a value of 1. Okay? So, the easiest ones to decide are the ones that are impossible and the ones that are certain. Which one's impossible up here? Rolling an 8. This is impossible.
I've seen 9-sided dice.
We're talking about a cube.
A number cube. It's not going to be 9-sided if it's cube.
Whoa.
This is impossible. In other words, it's at 0. Which one is certain?
Rolling a number less than 7.
This is certain. In other words, it's at 1. Hmm?
At the bottom or?
Just beside it. It's certain. It has a possibility of 1. The next ones that we should look at are the ones that are right in the middle. They're either as likely as not. Which ones are in the middle? The one that has a 3 in it. Because how many sides are on the dot? 6. So 3 out of 6. This is as likely as not likely. In other words, the probability of these two happening would be 50-50, half. Once you've determined where that half is, you can figure whether it's less likely or more likely. Is it closer to 0 or is it closer to 1? So, anything that's less than a 3, I see 2 of them that have 2s. Those are what? Those are less likely. Which means they're close to what? Close to 0.
I thought it was like unlikely.
Yeah, unlikely, less likely. Okay? Not likely it's going to happen.
Would these be like 0.25?
Okay? Well, this would actually be, here, 2 out of 6 would be 1/3, 0.3333. If I did it as a percentage, 33%. Okay? And then the ones that are more likely would be the numbers that are greater than 3. In other words, they're closer to 1. So, on one piece of your assignment tonight, you're organizing data that way. You're deciding, is it going to be certain to happen? Is it something that is impossible? Is it something that's 50-50? Or is it closer to impossible, or is it closer to certain? Everybody kind of understand the concept? We good? Okay. Then if you'll turn to the pages where your turn is, number 4 and 5. It says find each probability, write your answer in simplest form. So they want us to leave it as a fraction, but they want us to simplify that fraction. Picking a purple marble. When you're writing the probability of getting a purple marble, it would look like this. P of purple. Okay? When I go to calculate this, you do the total possible outcomes in the denominator. How many possible outcomes are there in this situation? 20. And in the numerator, you put the number of times that this event could occur. Say 10.
Wait, so why do we say purple? It's like,
This is the probability of getting what? Purple.
they're the same.
So, what's the probability of getting a purple? 1/2. In simplest form. in number 5? Probability of greater than 4. Total possible outcomes. Total possible outcomes on a die. How many? 6. How many of those numbers are greater than 4? 2. And if I simplify this, this is 1/3.
My answer
I know your homework is.
Okay? I bet you don't. I really encourage you. Go ahead, get started. Because you'll do the wrong ones.
Well, it's at least number 1, I know that. At least two.
Okay. I want to talk about using the complement to find something. When you're talking about the complement, you're talking about the opposite of it. So if I was talking about the probability of heads, the complement would be the probability of tails, not heads. Okay? When I take the probabilities of heads and the probabilities of tails and add them together, it always has a value of 1, which is what this is telling me. The probability of an event taking place plus the probability of not that event, which is what the complement is, anything but that event, always adds up to 1. And in number 7, on your turn, they're asking us to find the probability, and I know there's easier ways to do it. You could probably do it in your head. But they're asking us to use this complement idea to find this answer. So, a jar contains 8 marbles marked with the numbers 1 through 8. And you're going to pick a marble at random. What is the probability of, notice it says, not picking the marble marked with number 5? What's the probability of a 5? 1 out of 8. So if I take 1 out of 8, the complement, which would be not a 5, should be equal to 1. Algebraically, what would I do to get this probability here by itself? How would I get rid of this 1/8?
You keep the 8, but for the numerator you put the
What would I do?
Subtract it.
I would subtract it. What is 1 minus 1/8?
7/8.
So they're asking us to use this concept of a complement to find the probability of something not happening. Make sense to everybody? And I know that this will work because 7/8 plus 1/8 equals 1. Use roll a standard number cube. Use the probability of rolling an even number to find the probability of rolling an odd number. Obviously, what's the answer?
1/2.
What's the answer? The answer is what? 1/2. Okay? Here's what they're saying. Take the probability of rolling an even number, which we know to be 3 out of 6, or 1/2, and use that to find the probability of an odd number, which is not even. And again, algebraically, what would I do to get rid of the half? I'd subtract it. So you're always going to take 1 minus whatever the probability of that event is to find the probability of not that event, the complement of it. Everybody okay? We all good? All got it? You're sure?
I'm 100% positive.
Oh, I was wrong. I saw this.
And I very seldom assign which problems. usually assign evens, but I felt a little odd today.
For the win.
Ting!
Con Master 2016.